everyone. Today we are going to discuss about histogram based techniques. So with two session objectives, namely to understand what is histogram of an image, and my second objective is to apply histogram equalization to enhance the given image. So first we need to understand what is histogram. So to understand the same, I would like to take a small image of size 4 cross 4. So if I take an image as a matrix f of x comma y, which is equal to, I would like to take it as a 4 cross 4 image. So I will have 4 rows and 4 columns. So just for a simple example, I would like to make my intensity values as 1, 2, 3, 4 in my first row. Similarly, 5, 5, 6, 6. Third row, 6, 7, 6, 6. And last one, 6, 7, 2, 3. So in total, I would like to represent this image as a gray image. So the number of pixels available in this image is 4 cross 4, which is equal to 16. The maximum intensity in this image is, which is equal to, the maximum intensity is 7. So when I have 7, to total number of bits I could able to use as 3 bits, 1 1 1, which is a binary representation of my maximum intensity. So if I take this, I have to make my pixel distribution as a small tabular column, that is my gray level and the number of pixels with respect to that particular gray level. So number of pixels with respect to that particular gray level. So gray levels are 1, 2, 3, 4, 5, 6, 7, which represents the intensity in my image starts at 0 actually. So I missed out 0, sorry, let me include that too. So I missed out 0, that is 0, 1, 2, 3 to 7. That is maximum intensity. So number of zeros available in my image is 0. Similarly, number of ones, that is I have only 1. Number of twos, 1, 2. I have 2. Number of threes, 1, 2. So I have 2. Number of fours, 1, only 1. Number of 5, that is equal to 2. Number of 6 or 6 here, 1, 2, 3, 4, 5, 6. Number of 7s are 2. So the total number of pixels are 0, 1, 3, 5, 6, 8, 14 and then 16. So I am meeting my requirement. So this is what we call it as histogram. So I would like to represent the same with the help of MATLAB. So here in my MATLAB, I would like to use the code to represent the histogram of the given image. So let me read my image, which is I is equal to im read. I have two images in my drive, namely baby in capital and another one is before. So first let me take before. That is before in the sense I have captured an image in a dark region, so the image is not clearly visible one. So I would like to make it as before. Let us see it in the near time. This is represented by using JPEG image format, and this image I would like to read it in the variable called I. Right. So this is spelling mistake is there. I am read. So I would like to read my image in the variable I. So let us visit what is the histogram of this particular image. So I would like to represent the same. Prior to that, this is a color image. So first let us conclude this color image into gray image. G is equal to RGB to gray, which converts your color information into a gray information. So this G will be a gray image. Now let us see what is the histogram of this particular gray image. You can also see the information here. This I is a color image of size 472 cross 640 which has red, green, blue component. I am converting it into gray, so which has 472 cross 640 once again, but the values are in integer, that is unsigned integer 8. The minimum pixel value of this particular image G will be 0 and the maximum pixel intensity will be 255 since it consists of 8 binary representation, that is 8 bit in each and every pixel. So if we see the histogram of this particular image G, it will be look like, let it load. You see the intensity distribution you can easily visualize. So at 0 I could not find any pixels. Around here I have most number of pixels. Right. So this is the representation of histogram. So histogram is the representation of pixel distribution in the given image. It is not only for image, it is also applicable for the given data. Now we are moving on to our second objective, to enhance the given image by equalizing, which means we are going to distribute this particular gray information. You see, the most of the gray levels are occurs between 40 to 60, not beyond. But actually, as it is a gray image, the pixel intensity should be distributed from 0 to 255. But here the entire pixel values are distributed between 30 to 60. So that is what our second objective, to apply histogram equalization to enhance the image. So for this, let us first take the steps involved in equalizing the given image. There are only 4 steps which we can strongly get it. First we have to find cumulative histogram. So we have to find cumulative histogram. So we know what is histogram. The histogram is the number of pixel intensity, that is distribution of your pixel. Second one, after finding cumulative, we have to find the normalized value. Normalized value of your histogram. Normalized value in the sense what? The total number of pixels should be divided with your actual value. Then third one, multiply your normalized value by the maximum gray level. The maximum gray level for a binary image, that is 1. For a gray image it will be 255, right? For color image also it will be 255 in each and every color component. And last one, after finding this, that is the third step will give you one result, no, that has to be replaced with your existing value, right? So that let us check. So we will take the same example, that is apply histogram equalization for the given image. This is what we have taken into our account to find histogram. Here this is our histogram. We have to consider the same. So now we are going to apply these 4 steps into this particular image to find equalized information. So let us make our tabular column. The first value is your intensity. So let us take our intensity as RK. The intensity values are 0, 1, 2, 3, 4, 5 and then 6, as it is 0 to 7. So I missed out the last one, that is 7. Now the number of pixels available in each intensity that we have to make. So that is once again we have taken it here, so the same that we are going to represent once again 0, 1, 2, 2, 1, 2, 6, 2. That is, in each value that is going to be represented here, which is equal to 0 represents with 0, 1, 2, 2 number of pixels, 3, 2 number of pixels, 4, 1 number of pixel, 5, 2 number of pixels, and 6, I have 6 pixels, and 7, I have only 2 pixels. So what is our next step? After finding this, we have to get the cumulative histogram. So find the cumulative histogram. Find the cumulative. This is 0. 0 plus 1 is equal to 1. 1 plus 2 is equal to 3. 3 plus 2 is equal to 5. 5 plus 1 is equal to 6. 6 plus 2 is equal to 8. 8 plus 6 is equal to 14. And lastly, 16. This is our cumulative. After getting cumulative, what we have to do? We have to normalize the same. How to do the normalization? To divide the entire sequence with a maximum number of pixels, that is total number of pixels. What is the maximum value in your cumulative pixel? So that is, maximum value will be always the total number of pixels, that we know. So I need to find the normalized one, so get a cumulative divided by the total value. The total value is 16. So 0 divided by 16. Excuse me. Let us make it like this: 0 divided by 16. 1 divided by 16. 3 divided by 16. 5 divided by 16. 6 divided by 16. 8 divided by 16. And 14 divided by 16. Lastly, 16 divided by 16. And what is the next step? After getting your normalized value, we have to multiply the same with the maximum gray value. Here in the given problem, you carefully check 1, 2, 3, 4, 5, 6, 7. The maximum intensity is 7. So that is what available. So this we have to consider. If the maximum intensity varies in the given image, we have to consider the same. For the gray values, that is for the gray image, the image which contains 8 bits, if it contains 8 bits, the maximum intensity will be 255. That is what I need to consider when it is a gray image. Here in this example, the maximum intensity is 7, so I have to consider the same. So this we have to multiply with 7. So multiplied by 7. So multiply by 7. So divide this and then multiply it with 7. So repeat for all this: 7, 7 and 7. Get the values. So when you do, this is 0, the value will be equal to 0. Now 1 divided by 16, which is multiplied with 7, which will be around. If you want to use calculator, we can use calculator, and if you could able to do, you can directly do that. So let me take calculator to find. Sorry, I found. You see, the values are 1 divided by 16, which is equal to 0.06, and that is multiplied by 7. So I'll get it around 0.43. So this we have to consider here. That is, it is going to be 0.43. And next one, this will be 1.31 something. And this will be 2.18 something. This will be equal to 2.62. And this will be equal to 3.5. And this will be around 6.125. And this will be 7. Now we have to take this value which is to be replaced with the existing value. Since the pixel intensity cannot be in fractional value, I have to round it off. So do that, round it off. 0 will be 0, 0.4 which will be also 0, 1.3 can be considered as 1 when you do round off, 2.18 2, 2.6 which will be 3, 3.5 will be 4, 6.1 will be 6, and this 7 will be remains as 7. So this intensity which I need to replace. So the values are 0 to be replaced by 0. So I do not have any 0 in my image, so I can directly take it, right? And next one, the 1 is to be replaced by 0. How many ones I do have? I have only this one, so replaced by 0. And 2 to be replaced by 1. How many 2's I have? I have 2 2's, so those are 1 2. So this to be replaced by zeros. 3 to be replaced by 2, 3 to be replaced by 2, and sorry, similarly 4 to be replaced by 4 to be replaced by 3, and so on. So the replacement values are replaced. 5 which I need to replace by means of 4, 5 I need to replace by means of 4, so replace 4, 4. 6 I need to replace by means of 6 to be replaced by 6. So 6 will remain same. 6, 6, 6, 6. This one is 6 and this one is also 6. 2 to be replaced by 2. So this 2 will remains 2. Right? 7 to be replaced by 7. So this remains 7. And 3 to be replaced by 2 and this will be 2. Right? Am I right? 2 to be, sorry, 2 to be replaced by 1. So this I need to replace by 1. I'm sorry about that. So 0 1 2 3 4 4 6 6 6 7 6 6 6 7 1 2. So this is what equalized one, that is the intensity distribution will be in the entire range of the given image, right? So this, let us look into an example of this same, right? So we will consider a small histogram equalization. So now I have taken one image in which I have converted the same into gray. So let us see how it exactly look like. So I would like to go with a new figure, a subplot of, I would like to have one row, two column, and the first image which I would like to show my gray image. So where I no need to worry about this histogram equalization. So let us project what exactly the image look like. So this is the image. I hope you could able to see the image, right? So now the image may not have a clear information. So what I am going to do, I am going to equalize this image by using histogram equalization. So the output image, which I would like to call it as O, and I would like to equalize the histogram of equal H ISTEQ, which represents histogram equalization of the gray image. After equalization, I would like to project the same along with the existing one, the plot 1 2 2, right? So that is going to be your IM show of your output image O, right? So this, before projecting, let us project our first image. I would like to project our first image, and now I would like to project the output image along with that. So this is the original image, this is the histogram equalized image. You could clearly see that this has the low intensity since it is captured in a dark area. Now when I equalize, I could able to understand what exactly the information available in this.